Alright, welcome back. Part 3. How do you recognize a discrete distribution? Remember, discrete means countable integers. Um, Something that comes from a counting process. How many trees are in my backyard? I don't have 10 and a half trees. I got 10 or 12 or 3 or whatever. How many cars do you have? 7, 4. How tall is Jim Bob? Well, height is not discrete. Height would be continuous because you could have 5.5 feet. You could have 5 3/4 feet. Okay? That's the difference between discrete and continuous. All right, move right along. 13. Expected value is simply the mean. The way you find expected value, you multiply the value times the probability of it occurring, and you add them all up. It's really that simple. And that's going to be your mean. And here's the formula. Here you see it, but it's going to be 35,000 times your 0.4 plus 45,000 times the 0.3, so forth and so on. And that's it. 14. How do you recognize a binomial experiment? This kind of describes it, but the main thing, look for a set number of trials, and you always have the probability of success or failure, and your probability is always going to be set for each trial. So remember that. So just look over those type problems. Here, an advertising agency is hired to introduce a new product. The agency claims that after its campaign, 61% of all customers are familiar with the product. Okay? So they're either familiar or they're not familiar. 61% say they're familiar. How many say they're not familiar? Well, it's going to be 100 minus 61, which is 39. So here we ask 7 randomly selected customers whether or not they are familiar with the product. So we got out of 7. That's our set number of trials. Is this binomial? Yes, it is binomial. And because it has all the characteristics that we just described. Here, use the correct formula to find the probability that out of 7 customers, exactly 4 are familiar. And let's use our software. You can use mini tabs or you can use StatTrek. I think StatTrek would be easier for this one, but it doesn't matter. I'll go to StatTrek and show you. Let's go to StatTrek. Here, the software. It's going to be binomial. And then with StatTrek, as soon as it comes up, and it was up, maybe I have too many sites up, doing too many things at once. Here, probability of success on a single trial, I believe that was 0.61. Number of trials, I believe that was 7, because I believe it was 7 customers. So I'm going to type in 7. The number of successes, I believe they wanted exactly 4, so I'm going to type in 4. I'm just going to hit calculate, and it gives you your solution. And I believe my solution is x equals 4.287, so forth and so on. And I think that's it. There's our solution. Again, you could do this in mini tabs as well, but I think it's easy. We'll do the next one in mini tabs. 16 says, how do you recognize a Poisson experiment? The main thing, you're looking for a mean. You're looking for some average value in an interval, space of time, something. Number 17 here, the mean number of cars per minute going through the Eisenhower Turnpike. Automatic total is about 7. See, that's my mean. Find the probability exactly 3 will go through a given minute. Alright, that's going to be mini tabs. Let's go to mini tab and use that. Okay, mini tab, few ways. One way you could do is go to graph, probability distribution plot, view probability. Go here, go to Poisson, put 7. That's the mean, shaded area. Let's do x value. We don't need left or right tail, but we have to type it in if you're going to do it this way. So I'm going to just type in 3 here and type in right tail, and I'll show you what I'm talking about. I don't need the right tail, but if I need it greater than 3, it would be this value, but I only need exactly 3. So if I just click here and put my cursor over this, it gives me the exact value for x equals 3. It's 0.0521. And I think we're going to be moving on to the next part of this presentation.